Okay, in this video, we're going to talk about the relationship that exists in a circle between the circumference of a circle, which is the distance around a circle. Okay, so remember that this circumference is a distance versus the distance of like one of the arcs, right? Which is usually from a central angle. This is called a central angle. It starts here in the middle of the circle and goes out two radii go out and form an arc. Okay, so the relationship between the arc and the circumference and how that's related to the area of a circle, also the area of what's called a sector, okay, which is just a portion of the circle, again starting at the center, two radii going out, and this part here is called the sector, and the relationship between that and the number of degrees of the central angle, okay, and the whole 360 degrees of a circle, right? Actually, you can go between the number of degrees and the area. You can go between the number of degrees and a circumference. You can go between a circumference and an area. You can use proportions, actually, to find out other pieces of information. All right, just put that in there. Proportions. By just knowing these two simple formula, okay? So let's talk about an example. Now, I'm going to let me just go ahead and use this one. Let's assume that this particular circle here, again, remember, you have to have a central angle. And again, remember what the definition of a central angle is. It's an angle that starts at the center of a triangle, and there are two radii that move out from there, and it forms a portion. It goes all the way out to the edge of the circle, right? Now, let's look at this first one over here, and we're going to find the proportion between a distance and an area. All right. Now, let's say that this particular sector here, right, or this particular length, all right, is the length, arc length. Let's just put that in there real quickly. Let's say this arc length has a distance of 100 inches, okay? And we don't know the area or the whole circumference of the circle, but we do know that it's 2 pi r, okay? So we know that. And let's say over here, we also know that, let's say this particular sector, which would be this part right here, right? Has an area of, let's say, 120 square inches, right? Because area, remember, always has inches. And that the area of the complete circle, these are pieces of information, the area of the complete circle has, let's say, 360 square inches. Now, and the question is, what is the circumference of this particular circle? We don't know anything else. We don't know the radii. We don't know anything else about this particular circle, okay, other than what we just said here. You can actually set up a proportion to solve for this. I can say that the relationship between this arc length to the entire circumference, okay, so we'll say 100 inches is to the entire circumference, We'll just use that as a C. And it should be proportional to the area of this particular sector to the whole area of the entire circle, which we said was 120 square inches over 360 inches. Now, again, we're not using this particular one here. We're just using this one here, right? So the relationship, again, between this arc length and the entire circumference should be proportional to the area of this sector to the area of the entire circle. And we just set it up as a proportion. Now, remember that circumferences and arc lengths are distances, right? So they're going to be measured in either centimeters, millimeters, inches, feet, depending on the size of the circle. But areas are something squared, right? So square inches, square feet, square millimeters, whatever. And once you've set up this proportion correctly, you can go ahead and solve for it. Now, I know, step 2, I know, for example, that my inches squared will cancel out, right? And I'll have 100 inches is to C, which is this entire circumference is what I'm looking for, as 120 inches squared is to 360 inches squared. These cross out. I can reduce this to 1 over 3. Step 3. I can say 100 inches is to C as 1 is to 3. Do my cross products. And I end up with 300 inches divided, 300 inches is equal to C. And again, that'd just be 1C. This would go up here, this would go over here, and 300 inches is equal to C. So I just found that the circumference of this circle is equal to 300 inches. Now, you can set this up, again, any way you want. Let's say I want to do it with the number of degrees, for example. I could say, and let's come up with a different problem. Let's say that I know that this particular number of degrees from my central angle, let's say is 90 degrees, okay? And I know that all circles have 360 degrees. And let's say I know that this particular area of this circle is, let's say, 240 square inches. And I want to find the area of this sector. Well, I just went ahead and set up my proportion, and it should actually work. Let's see what happens. So degrees cancel degrees. I can reduce this, right, 90 over 360 to 1 over 4, right, is equal to the area of my sector over 240 inches square, right? And again, what am I trying to find? I'm trying to find the area of this sector. So I know my answer is going to be in something squared. We'll do cross products again. First step, second step, third step. This is going to be 240 inches squared. Should be equal to 4 times the area. Again, divide both sides by 4. Crosses out. And I'm left with 240 divided by 4, which is 60 inches squared. Will be the area of this particular sector. Okay? So again, what's the purpose of this video? I'm trying to show you how you can use proportions to go between the circumference, which is the distance around a circle and an arc length, which would be proportional again to the area of a particular sector to the area of an entire circle, which is also proportional to the number of degrees of a central angle to the 360 degrees of a circle. Okay? I hope this was helpful.